Sometimes when you have an equilibrium system, you don't always start with the reactants. Typically in a chemical reaction, you start with the reactants and the reactants start to produce products. And then in an equilibrium system, those products will react with themselves and reform the reactants. Okay, but what happens if you're in an equilibrium system and you don't start with just reactants? What if you start with some of the reactants and some of the products? For example, let's say we have N2 and H2 in equilibrium with 2 NH3s. Okay, normally you would just start with those. Okay, but what if you start with, well, let's back this up here. What if you just start with NH3? What if you put some NH3 into a container and just let it go? What's it going to do? Of course, the reaction is going to proceed to the left, which means some of that NH3 is going to break down into N2 and 3H2, again, until you reach equilibrium. So if you start with some reactants, of course, the reaction is going to begin by proceeding to the right. And of course, if you start with some products, like we just said, if you start with NH3, the reaction is going to proceed to the left. Okay, but what happens if you start with some reactants and some products? Then, which way will the reaction proceed? It depends. And it depends on what's called capital letter Q, which we refer to as the reaction quotient. Okay, the reaction quotient is the same thing as the equilibrium constant, except you use the non-equilibrium values. You use like the initial values to compare. So, you're going to find the value of Q using the same equilibrium products over reactants raised to the power of the coefficients. And then you're going to compare Q to the equilibrium constant. Okay, if Q is greater than K, then the reaction is going to proceed to the left, and the left is the reactant side. Okay, notice that the larger than or the greater than mouth is open to the left, and so it proceeds to the left, making more reactants. If Q is less than K, again, always put Q on the left-hand side. Notice the greater than is open to the right. The mouth is open to the right. The reaction will proceed to the right, which will form more products. And then, of course, if Q is equal to K, then you're already at equilibrium, and it's not going to proceed in one way or the other. So here we can kind of see this. If Q is greater than K, then it's going to proceed to the left to form reactants. If Q is less than K, then it's going to proceed to the right to form products. Now, why does that happen? Well, think about what the equilibrium constant is, okay? Whether it's Q or K, that's equal to the concentration of the products over the reactants. Okay? So let's look at this one here. If Q is greater than K, the equilibrium constant doesn't change. So for Q to get back down to the equilibrium constant, it has to go down. The value of Q has to go down. Well, how do you make a fraction smaller? How do you decrease the value of a fraction? Is you make the numerator smaller and the denominator bigger. So you can see here the products are going down, the reactants are going up. What does that mean? The reaction is forming reactants. Okay, when Q is less than K, Q has to go up to reach K. And in order for Q to go up, how do you make a fraction get bigger? The numerator goes up, the denominator goes down. So the products are going up, the reactants are going down, which means you are forming more products. Okay, let's take a look at this. Example 1 says a mixture of 122 atmospheres of hydrogen, 61.2 nitrogen, 87.3 ammonia is placed in a 1 liter container. Kp for the synthesis of N2 from its elements is 2.79 times 10 to the minus fifth. So the equation, I just wrote it up there, is going to be in equilibrium with this. And they tell us the Kp value is 2.79 times 10 to the minus fifth. And then it says calculate the value of Q to determine which way the reaction will proceed. Is the reaction going to proceed to make more NH3, or is it going to proceed to the left to make more N2 and H2? So the Q value, again, is equal to, just like the equilibrium constant value. Okay, but notice it says a mixture of this and this and this is placed in a 1 liter container. What that tells you is that those are the initial values. Those aren't the equilibrium values. Those are the initial values. So anytime you're not at equilibrium, you use Q. So we're going to take the pressure of NH3, which is 87.3, and because that 2's there, we're going to square it, over the pressure of N2, which is 61.2, and then the pressure of hydrogen, which is 122, and we're going to cube that because there's 3 hydrogens. So 87.3 squared divided by 61.2 divided by 122 raised to the 3rd power equals 6.86 times 10 to the minus 5th. Now, again, when you set up the greater than less than, always put Q on the left. Put K on the right, because then the way that the greater than less than sign is pointing will tell you which way the reaction is going to proceed. So, here's the Q value. Here's the equilibrium constant value. Which one's bigger? Okay, 6.86 times 10 to the minus 5th or 2.79 times 10 to the minus 5th. Since the exponents are the same, whichever number is bigger, that's the bigger number. So 6.86 is larger than 2.79 times 10 to the minus 5th, which means Q is greater than K, and then notice that that greater than sign is pointing to the left. So what's going to happen? The reaction is going to proceed to the left, forming more N2 and H2. Those are on the reactant side. Okay, let's look at one more example here. The equilibrium constant Kp for the reaction above is 51. So we know Kp equals 51 for that reaction. Use Q to predict how the reaction will proceed to reach equilibrium at 448 when they give us those initial values. So again, Q is going to equal the pressure of HI, and that's got to be squared. So that's 0.592 squared over the pressure of H2, which is 0.296 times I2, 0.888. Okay, and then I take 0.592, I'm going to square it, divide it by 0.296, divided by 0.888, and I get an answer of 1.3. So therefore, Q is less than K. Q is 1.3, K is 51. So Q is less than K, which means that the reaction will proceed to the right, forming more HI. Okay? And so that's how you use Q. Anytime you're in a situation where initially you have some reactants, but you also have some products, then you have to determine which way that reaction is going to proceed. And typically it's going to say use Q, find the value of Q, or they'll simply say, I believe it was in the previous problem, which way is the reaction going to proceed? Anytime you see which way will the reaction proceed, they're asking you a Q versus K question. And so using that information to determine, oh, Q is either greater than or Q is less than K, will tell you it's going to proceed to the left or it's going to proceed to the right.